All right, today we're going to go over the STARS review, STARS push booklet, just a little bit, the first few pages, and hopefully give you a better understanding of it. If you look at the first box, it says name and describe each part of the element below. So we'll start with the top of this box, which each box is indicating a different element on the periodic table of elements. So that 14 asks for the part in the description, where the 14 represents your atomic number. That's why I wrote the A and then the little number sign next to it. Your atomic number tells you your number of protons, which in turn your number of protons gives you the identification of the element. The SI is the element symbol. The 28.086 is your atomic mass, which tells you the mass of the element. And since we know that 28.086 gives you the mass of the element, we also know that your total weight of your element comes from your protons and your neutrons together. So that atomic mass also helps you find out your number of neutrons, because if your protons and neutrons give you the atomic mass, we can simply subtract our atomic number here, which is 14, also our number of protons, from the atomic mass and get our number of neutrons there. Of course, you would have to round off the 28.086 to 28, the nearest whole number, before you did the subtraction. And the last thing in that box is your element name, which is silicon. Moving on down, it says fill in the table. It asks us what are the charge of each. Well, we know our charge for protons is a plus. Our charge for electrons sounds negative to me, and so we automatically should know that electrons has a negative charge. And your neutrons sounds a lot like the word neutral, and so your neutrons don't have a charge. That's why I wrote the 0. Your atomic mass size, since your protons and electrons, I'm sorry, I wrote that wrong. Since your protons and neutrons make up all of the weight, they each weigh, all of the weight of the atom, they each weigh 1 atomic mass unit, and that's why I wrote 1 AMU. Your electrons don't have a weight at all. They're outside in the electron clouds. So let me scratch through that. As you see, even Coach Smith can get in such a big hurry that he makes mistakes. I'm glad I caught that. All right. So all of your weight is in your nucleus. The only two items in your nucleus, or subatomic particles in your nucleus, are your protons and neutrons. So they each weigh 1 AMU, while your electrons don't have weight. The location of your protons is in your nucleus. Your location of your electrons is in your electron cloud outside of the nucleus. Remember, people don't like negative people around them. So then protons and neutrons don't like negative things around them either. So they kick the electrons out. That's why your protons and neutrons are in the nucleus and your electrons are outside of the nucleus. Moving on down. All they simply wanted you guys to get from this groups and periods was that, remember, you read your groups down and your periods are read across. So hopefully you figured that out and just filled in GROU, and they gave you the P going down and then your PERIOD going across. Moving up to the top, ape man. What is the meaning of ape man? The ape stands for atomic number. The A in ape stands for atomic number. The P stands for protons, and the E stands for electrons. What that is telling you is they all actually mean the exact same thing. Your atomic number, if you look over here at this box, is 14. That tells me my atomic number is 14, which also means that my number of protons is 14, and my number of electrons is 14. Whatever any of these numbers is, your other one is going to be the exact same. For instance, if my number of electrons were 10, my number of protons would be 10. That means my atomic number would also be 10. So 8 just means each of these things are equal. Your atomic number, your number of protons, and your number of electrons. The man part of it, I know I taught you guys with 1 N. They put 2 here because they were just writing out the whole thing, atomic number. So your atomic mass minus your atomic number is going to always give you your number of neutrons. So you look at the box over here, this is my atomic mass. If I subtract my atomic number, it's going to give me my neutrons. So if I'm ever trying to figure out my neutrons, all I have to remember is that man part of 8 man. And what I suggest is, as soon as I got my test, I'd write that on there as a strategy, 8 man, and write out what it means. Atomic number equals protons equals electrons. Man was atomic mass minus atomic number. It's going to give me my neutrons. That would help me greatly on my test. Moving on down. Rules of the nucleus. To find the charge of the nucleus, look at the positive protons. The charge of the nucleus of silicon is what? Now, how do we know that the charge of a nucleus is always positive? Well, because there are no electrons allowed. So if there are only positives and neutrals inside of the nucleus, which is your protons and neutrons, then that means the charge has to be positive. So to figure out what that charge is, we just count how many protons are in the nucleus. Now, we look at silicon, we don't have to do any counting because the box is right here. And we know that the atomic number is the same as your number of protons. So the charge of that is going to be how many protons there are. So the charge of silicon is going to be, of the nucleus, make sure you're clear on that key word, of the nucleus of silicon is going to be 14, because inside of that nucleus there are 14 protons. The charge of the nucleus of oxygen, the nucleus again is your key word. In that nucleus alone, not the whole atom, but in that nucleus, what is the charge? So we just look for the atomic number of oxygen. The atomic number of oxygen on our periodic table. Here's oxygen, I'll zoom in. Is 8. Your atomic number is 8. So that means that I have 8 protons. So that means that my charge of the nucleus is 8. Now suppose they say, what is the charge of the overall atom? Well, if they say, what is the charge of the overall atom, they're talking about everything together. And of course, your electrons are equal to your protons, so they cancel each other out. And so you would have a neutral charge of a regular atom. But since we're only talking about the nucleus here, then you're going to have a positive charge. At the bottom, the Bohr model of an atom. Energy levels or shells. The first energy level holds up to 2 electrons. The second and third energy levels each hold up to 8. Now when they say energy levels, they're talking about those energy rings that go outside of the nucleus there. That's what they're talking about. So that first one holds up to 2 electrons. The second one can hold up to 8. And the third one can hold up to 8 electrons. On your Bohr model. Look at the last energy level to determine reactivity. If the last energy level has 8 electrons, then it is, well, if the last energy level has 8 valence electrons, we consider that to be stable or full, non-reactive. So full is one thing, non-reactive, and the most important is to realize that it is stable. Full, non-reactive, and stable is your most important thing to realize. Because if it has 8, that means it's in group 18 over here, which is our noble gases. Alright, remember what I told you about noble people. They didn't like to blend in with their peasants. Well, your noble gases don't like to blend in with any of the other ones on the table. They're solo, so they are stable. Alright, if the last energy level is 1 or 7 electrons, it is considered to be very reactive. Why is helium in group 18? Well, the reason it's in group 18 is because, think about helium. It's going to have 1 energy ring. And how many electrons did we say fit on that energy ring? We said only 2 can fit on that one. So that means that it is full. It is stable. Alright? Non-reactive. That's why that one is in group 18. It is also considered to be one of the noble gases. Alright, this is page 7 of your Star Push.